Inhibition means partially or completely blocking the cross-linking of silicones. It is usually caused by the catalyst in the silicone being deactivated and is also known as poisoning the catalyst. Curing problems due to inhibition frequently arise when using platinum-catalyzed silicones. Tacky surfaces can be one sign of this. The following 3 examples illustrate this quite well. ELASTOSIL RT 702 is applied once on Teflon and once on standard tire rubber. The product is then cured at elevated temperatures as usual. The sulfur contained in the tire rubber poisons the catalyst and prevents the silicone from cross-linking on the contact surface. The surface remains tacky as a result. The material applied on clean and/or non-inhibiting surfaces cures completely and is tack-free. Even processing addition curing silicones together with condensation curing silicones generally produces contact inhibition. In this case, it is the tin compounds in the condensation curing silicones that poison the platinum catalyst. Silicones that contain titanium catalysts instead of these tin compounds do not exhibit this behavior, however. This means that an addition silicone like ELASTOSIL RT 601 can be processed along with a titanium-catalyzed grade, such as ELASTOSIL N9111. Combining this with a tin-catalyzed grade, such as ELASTOSIL N189, however, produces the contact inhibition mentioned earlier, as evidenced by a runny, tacky surface. Inhibition extending beyond the surface can prevent cross-linking from occurring at all. This can be demonstrated with RT 601, an RTV2 silicone. ELASTOSIL RT 601 is placed in a clean beaker and in a dirty beaker. Stirring spreads the contamination throughout the silicone. The silicone in the clean beaker completely cures at room temperature within 24 hours. The silicone contaminated with an inhibitor, however, only partially cures. It only reaches a liquid to gel-like consistency.